Good evening and welcome to Data Center. We'll be looking at linear regression as well as multiple linear regression, and then we may as well look at binary logistic regression. Now, for you to be able to run for linear regression, the following condition must be ascertained. First, your data must be linear. Under condition, the data must follow normal distribution. Okay. Now, for you to be able to measure the linearity of your data, we talk about the P-Pplot for linear regression. And then for normality, you can either plot it on your histogram or you used Kolmogorov, Smirnov, or Shapiro-Wilk. It's also important that your dependent variable is continuous data, while your independent variable or control is categorical. Okay, so these are the assumptions that your linear regression must fulfill. Then we also have multiple linear regression. Okay, let's quickly have an exercise on the linear regression. So I have the data set here with student score in physics, chemistry, mathematics, economics. Okay, and the following classes we have let's put this. We have for SS3, SS1, SS2, that is for senior classes, and then we have the gender. Okay, now this is their score. Now we can check to see the relationship or the effect, okay, of this class on chemistry. You can see if there is a significant effect or impact as regards to the class or gender. And this, okay, we can use gender to see if the gender affects their performance. Or you can say, okay, the male students perform better compared to female students. Okay, so to do that, you go to analyze, you come to regression, then you click on linear. Okay, a dependent variable, we said it must be continuous. So let's assume we pick this, and then gender. Okay, now you come to your statistics. You have the model fit. If you need this, confidence interval at 95, confidence interval. Okay, if you need this, as well as collinearity. If you want part and partial correlations, you can as well click. Then this is where you select this plot. Click on this for your histogram. Okay, now we use our ZPRED, Z residual. Okay, then we click on histogram and normal probability plots. Okay, if you want all the partial plot to be produced, fine, you can click on these too. All right, continue. Options, that is if you want this. Okay, you can stop there. So the bootstrap, that is the numbers of steps we want you to perform the seed. Look at the web 1000 watts. I'm not performing bootstrapping now. Okay, so we just click on OK. Okay, so we have our descriptive table, we have our correlation, we have let's scroll down. It's a correlation table, and if you look at this using PNC correlation, you can see it uses diagonal. Okay, so this is for chemistry. At the significant level, you see this is it. This is gender. This this is showing the n. That is the correlation. This is correlation, the P value. and this is the end entry, numbers of row. You have 20 rows. Okay, you have 20 rows. Then let's scroll down, and these are model summary. These describe our model. Okay, we are looking at if this gender affects chemistry performance. Okay, look at this, the R value, the R square value, adjusted R, this the F change, significant F change. Okay, then we have our ANOva table. Then we have our coefficient table. Usually, why I selected this collinearity, it helps us to check if there's a multicollinearity in our data. Okay, so, and since it's 1, it's still acceptable. If it's more than 5, then there's problem. Okay, if you look at gender on this, it's not significant. Okay, gender on the performance. Okay, so we have a beta standardized value is negatively skewed, means these guys are not performing at all. Okay, then let's look at our assumptions. This is our assumption. This histogram is showing. Look at it. The peak is okay. Look at this. This is outside of it. And this is our P-Pplot. That is what we use for assumption test of linear regression. If you look at it, our data is linear because the points are closer to the straight line. Look at it. They are very close. They are not far from it. They are not far. So it means the data is linear. Yeah. So we just performed linear regression. Okay. So right here, I will showing us how to calculate. Then is a collinearity diagnostic table. I will be showing us how to run for multiple linear regression. Let's go back to our data set. The term multiple linear regressions means that you have more than one independent variable. Okay, you have more than one independent what? Variable. So I'm going to use these scam linear. We are still going to click on our linear, please. Then this time I'm going to add this to this, both the class and the gender on this. Okay, and all these we still maintain this. Click on our plots. Okay, if you want to save this, we click on studentize. If you're interested in saving, you save this. Okay, okay, so let's go ahead, please. Okay, we have our results, our descriptive table for gender, class, and the subject chemistry. Is a correlation table. That is this. Then these are model summary table. So it has changed. These are the predictors. We have class and gender. Looking at these predictors on chemistry performance. Okay, student performance. Okay, how does their respective class and their gender affect their performance in chemistry? Okay, if you look at this, we have class now. It's not significant. It means gender class does not necessarily predict student performance in chemistry. You see it. So it means that performance in chemistry is not stereotyped to the gender or the class of the individual of the students. Okay, so this is it. All right, so then we have a Histoplot 2. You can see this time around. We now have a longer bar close by in the middle. This to measure normality plots. Then look at this. It's still around it. So okay. So that is how to run for multiple linear regression. Okay. So with the coefficient table, you can as well predict the individual respective impacts or effects because it shows you their respective effects. However, the model summary will give you the composite description of it as well as your ANOva table. Okay. And if you look at it, you see they are related, they are all correlated. There's no difference between all the results you have. Okay. So we'll be stopping here tonight. I want you to practice and then go through it, ensure that every of the conditions are met before proceeding. All right, thank you for listening. See you same time, same venue.